Alright, so I'm going to look at questions like this, right? The set represented on each number line below in set builder notation. Okay, so what we have here is a number line, right? And then we have a dot at 4, we have a dot at 5, we have a dot at 6, and it seems like this set of numbers continues indefinitely because this arrow seems to indicate that this goes on and on and on till infinity. Okay, so I think then what we can then say is the following, right? We can say that x, right, is such that when x is greater than 4, and we say greater than 4 because values after, okay, 4 are included, but these values that are after 4 that are included are 5, 6, and so it goes. So this is x greater than or equal to 4. So we include 4, and then we also include numbers that are greater than 4. And that is x is an element, and we say x is an element of, now we could say natural numbers. Okay, and then we could use another close bracket. Okay, x such that when x is greater than or equal to 4, when x is an element of natural numbers. Okay, this is what we call set builder notation. Alright, so that includes 4, 5, and 6. And why we say x is an element of natural numbers? Because natural numbers start at 1, they increase by 1 all the way to infinity. So there is a jump from 4 to 5, from 5 to 6. So there's an increase by 1. Okay, and we are including 4, 5, and 6. Okay, let's move on to the second one. The second one says dot, dot, dot. So we include -5, include numbers -6, -7, and it seems like the arrow then indicates that we move on in the negative infinity direction. So we say x such that, okay, x is less than or equal to -5. Why do we say less than or equal to -5? Because the numbers before -5 on the number line are -6, -7, all the way to negative infinity. So -5 is included. That's why we write an equal to sign. Okay, and then we can say when x is an element of, now very carefully we say x is an element of integers. Why integers? Because remember, integers are positive and negative whole numbers. They increase and decrease by 1. So because we're dealing with negative numbers, we say x is an element of integers. There's no ways, right, that we can't say such. Okay, and that basically is fine. Okay. Let's look at number 3. Right. X such that, alright, so let's look at this. Number 3, we've got -7, -8, -9, -10. And the thing is, there is no arrow that indicates that these numbers go on forever and ever, the negative side. Neither there is an arrow that indicates that these numbers go on to positive infinity. So that means there's a limited value. There are limited values: -7, -8, -9, -10. Okay, so then what I'm gonna do is I'm going to say where x is what? Greater than -10, but less than -7. Now, since the dots indicate inclusion of -10, we are also going to say where x is greater than or equal to -10. And since we're also including -7, we are going to say where x is less than or equal to -7. But then we are going to say where x is an element. Now we need to check What type of numbers are these? These are integers, because remember, integers are positive and negative whole numbers. They increase and decrease by 1, and these numbers obviously from -7 to -8 to -9 to -10, in basically the interval of -10 to -7, all right, where basically we are all considering the integers that are listed there. Okay, let's move on to number 4. You can see here there is a shaded dot with an arrow this time round. So this indicates that all numbers in between, all numbers from -4, are basically part of the set of numbers that we are actually also taking into consideration. So we can say here x such that x is greater than what? -4. Okay, where x is an element of what? Real numbers. And why are we saying real numbers? Because real numbers includes both rational and irrational numbers. So obviously there's all the rational numbers and irrational numbers that are basically from -4 all the way to positive infinity. So that's why we basically say x is an element of real numbers. Okay. Let's look at this one. Okay. Oh, and here's another thing that I omitted. Oh, look at this. There's a lot of things I actually did not really take into consideration. This number, is it -4 or +4? It's actually +4. Is this number included? Yes, it is. So therefore we have to say x greater than or equal to +4. Sorry, I nearly made a mistake there with that problem. Let's look at this one. Okay, we're gonna say x such that, okay, let's not forget the curly brackets. Curly brackets are very important for set builder notation. Okay, so here we say x such that x is less than 7. Now we say x is less than 7. We don't include the 7 because there's an open dot. Open dot means we don't include that particular number that is basically represented beneath that number. Beneath that open dot. Okay, such, and x, we say x is an element of real numbers because the set basically includes all real numbers. Okay, all real numbers. So let's just remember, guys, that the shaded dot where we start and where we end means included, meaning we put the equal sign, but the open dot means not included. So that is why basically with saying x is less than 7, we don't include the 7 because there's an open dot. Open dot means not included. Shaded dot means included. So there must be an equal sign indicative of that. But when it's not included, open dot, there is no equal sign in the mix. Okay. All right.